Welcome to 8.8. Today we are solving systems of equations, and the cool thing about solving systems of equations is it helps us review chapter 8 without even knowing it. A quick little review again. Parallel lines, those are lines that never intersect, but then a second type of lines, they intersect. And where they intersect, that is what we're going to call today a solution. And so the first problem we did is we are going to see if this is a solution to both equations. And to be able to do that, just like we did before, we label this x, we label this y, and we check in both equations if one side equals the next. So here's our first equation. We're going to plug -3 in for x, 1 in for y, and we're going to see if it equals the other side. Well, -3 plus 1 is -2, and so we'd say yes. But to be a solution to both equations, it has to work in both of them. So next we have to try our bottom one. And once again, feel free to write this down. Please do. And then we get -3 plus 5 times 1. Then we know we have to multiply first. So we get -3 plus 5. And because that does equal 2, your answer is yes. And that, ironically, would be where the lines cross. Now, if it gives you a graph and asks you to solve the linear system, just look at the graph. Now, this is supposed to have this here. Sorry. Okay? And then, right here, if you notice, that's where our two lines meet. And then it's as easy as just writing that as a coordinate. 1, 2, 3, 4. Because it's always x comma y, we have 4. Because we go up 2, there's our solution. And once again, if it asks us to check our solution, we can just we can plug it into our equation. And it'll just check the first one for us. You're going to have -4 plus 2. Because -4 plus 2 does equal -2, it checks out. Then we're all happy. Now, the next step that is an amazing review for us is solving when we're given two equations and we're asked to graph. And so today, you're going to want some graph paper so we can be organized. I often like using two different colors so you can see the difference. And so this first one, I'm just going to use this blue color. Can you guys see this blue color?
Yeah.
Yes.
Okay. And if you notice, this is in slope-intercept form. Okay? It looks a lot like y equals mx plus b, right?
Yep.
Okay. What is our slope in this equation?
1.
1. Very good. Okay, it's the number in front of x. What is our y-intercept?
1.
1, because it's right there. Okay, I like it. What do we always graph first?
B.
Yeah, and because our y-intercept is right here, we put a 1 right there. Now, slope is what over what?
Rise
over
over
run.
Yeah, and we can put 1 over
1.
1, so we're just going to rise 1 and go to the right 1, and then go up and right 1. Or could we go down?
Yes.
Yeah.
Then what direction do we have to go?
Left.
Left. Great job. And then we're going to use a ruler. Now, I get to cheat a little bit because I have a line that graphs really nicely. Right there is our first one. Then we have to go to our second. And maybe you might want to rewrite it because it looks a little sloppy. Okay? Do you see that this is a -1/2? Okay. So what's our slope here?
-1 over 2.
Thank you, okay? Because once again, it's the value in front of x. Our slope is always the value in front of x. Our b value then is
-1 over 2.
-1 over 2. So they're both the same. So hopefully you got them right, right? What do we always graph first?
B.
The b value. And so we have to go to 0, 0, and we go down
1.
1/2, so halfway in between, right? Now, with our slope being -1/2, slope is what over what again?
Rise over
Rise over run. Very good. How do we rise a -1 from this point?
We go down.
Down 1.
And go left 2
Go
or the
right.
right.
Right, 2. And so we have to go halfway in between both blocks, and we go there. Because once again, the rise in -1 means down, and running 2 means to the right. So we can do it again. We go down 1, we go to the right 2. Now, what's the opposite of going down 1?
Left.
Up.
And up.
Let's go up 1, and then which direction?
Over.
Left 2. Do you see how this looks like it's still in the same line?
Mm,
Yeah, it's perfect. And let's do this in our nice little graph paper. Now, hopefully yours turned out as well as mine. Do you see where the solution is?
Yes.
Do you see that it's right here?
uh-huh.
0.
And how do we say that point, Jude?
-2.
Oh,
0.2.
no, how many times did we have to go over?
1.
And because we went over 1, is that a positive or a negative?
Negative.
-1. How much do we have to go up or down?
1.
We go 0.
0.
Oh.
So here's our coordinate. So we have to understand, once again, this is our x-intercept, that's our y-intercept. And coordinates are always labeled x, y. So, over 1. That's a -1. 0. We're going to do a few more, okay, just to make sure. But are we doing okay?
Yeah. Yes.
Okay, thank you. If you make a mistake, is it okay to fix it?
Yeah.
Yeah, and I hope you guys do, okay? That's why we're going through it. Now, what makes these different?
Because y has a 3 and.
Yeah, it's not in slope-intercept form, is it?
Nope.
No.
But what are you guys really good at doing? If we don't use y equals mx plus b, we learned a different way to graph. What's a different way we learned how to graph? What did we find?
Find the y.
No. What's the different way that we graphed?
Find the y. Y equals 0.
The y-intercept and find the
X.
x-intercept. Let's do that. Let's do that. So once again, to find, that's pretty funny. Okay, to find the x-intercept, how do we find the x-intercept again?
Plug 0.
And for what?
The
Y.
y.
Okay, so y equals 0. Let's write this right in our notes. So we have -x equals 1 minus, if we plug in 0 here, what is that going to be?
0.
It's going to be 0. What is 1 minus 0?
1.
0. Oh.
What's actually in front of x?
-1.
-1. How do we get x all by itself?
Posted by 1.
Divide both sides by -1. And we just found out that our x-intercept is,
1. 0. Huh?
what's 1 divided by -1?
0. No, 1. -1.
-1. Very good. So we can put our dot right where x is -1, and where's that?
And it's down. Down.
No, it's
So,
over.
Which
what?
way?
Left.
Left. There you go. Now, do we remember how to get the y-intercept?
Yes.
What do we plug in?
Plug in x 0.
Okay, cool. Do that, please. Okay?
Do you have any graph paper?
What kind do you need? Like, how many do you need?
Just Word.
So when we plug in 0 for y, oh, whoops, I did it backwards, didn't I?
Yeah.
I'm sorry. So we have 0 equals 1 minus 3y, right? What could we move to the other side?
Add.
Mm-hmm.
Add the
And
inverse.
3,
We could add 3y,
2,
right?
0.
So then we're going to get,
Negative
3y equals 1.
What's the best way?
and what's y going to equal then?
Y equals 3. Y equals what over 3.
Yeah, so y is like barely up there. Do you see that?
Uh-huh.
Okay. So then it's like barely lifting off. Let's see here.
What we do rise over roadblock?
No, because that's the x and the y intercept right there.
Oh.
Does that make sense?
We
Write
really-
that down.
Okay. So when we find the x and the y intercept, we just put a line in between the x and the y intercept as best as you can.
Okay.
Then we can choose to solve the x and y intercept, or we can get in slope intercept form. What do you guys like doing more? Because there's only one step we have to do to get it in slope intercept form.
Move the 3 over.
Should we just move the 3 over?
Yeah.
That will get it into slope intercept form, which is y equals mx plus b. Okay? So how do we move the 3 over here then?
Divide.
Divide. Very good. We have to divide. And so then we're going to get, well, 3 divided by 3 is not 0, it's
What?
1. So we have y equals
X.
x minus 3 all over
Y. 3.
3.
over 3. Now, if we do that, remember what we had to do here?
Expand.
Divide.
We had to split them
Split them.
because x is over 3, right? So it's actually saying 1/3 x, right? Minus 3 over what? 3 over 3. Both of these things are over 3. So we have to split them. Then we should simplify that once more, because what's 3 divided by 3?
Y.
And that is what we want to get it into. Now, when we get it into here, well, what's our slope?
1 over 3.
1 over 3. What's our y-intercept?
Negative 1.
Way to go. What do we always graph first?
Negative Y.
Let's do that then. Let's graph -1 on our graph paper.
Negative 1. Down 1.
Negative 3.
Now, what's our slope?
1.
Rise over go.
Rise over run. So what do we have to do here? We have to go
Up 1.
up 1 and over,
Over 3.
and then we have to go up 1 and,
Over 3.
okay, or we could go down 1 and to the
Yeah.
left 3. And then you do your best to connect all these points, and,
I don't know what this is. I don't know what it is.
what do you notice about these two lines?
Up.
This is kind of weird. What do you notice about these two lines?
That's called the pier line.
I don't.
I like how concentrated you guys are in making the right
They
lines with the right
still
colors.
get-
So, what's the solution?
It's nothing.
Solution?
Nothing.
No.
No solution.
Why isn't there any solution?
Because of that problem.